Hi, everyone, and welcome to the very first episode of the Vulnerability Report webcast series. My name is Asaf from the marketing team here at Vulcan, and with me today are Ortal and Jonathan.
Hi, my name is Ortal. I'm the research team leader in Vulcan.
Hey, my name is Jonathan. I'm a security engineer in the research team at Vulcan. Happy to be here.
In this webcast, we'll give you unique insights into the latest infrastructure and application vulnerabilities threatening your digital business. We promise we won't just read you the CVEs. Instead, we'll provide you with useful tips, tricks, best solutions, and remedies for the vulnerabilities that matter most. In this episode, we'll dive into the SIGRed and BootHole vulnerabilities and provide the best remediation patches and solutions for each. Now, this webcast was pre-recorded, so we won't be able to answer your questions live. But feel free to join our Slack workspace, Vulnerability Remediation Pros, linked right here at the bottom, where we'd be happy to talk.
So let's dive into SIGRed vulnerability, a very creative piece of research by Checkpoint. First, the dramatic title. 17 years old critical CVSS-based score of 10 and vulnerable vulnerability in Windows DNS Server that affects all Windows Server version 2013 to 2019. If I was a vulnerability manager, I wouldn't sleep at night after seeing those headliners. But what is SIGRed and why it is so cool? The main goal behind these features was to find a creative new way to get organization domain admin rights. Instead of the obvious, more straightforward use of SMB and RDP vulnerabilities to attack the domain controller itself, Sagit Sadiq, who published the research, found a cool and unusual way to achieve that by exploiting Microsoft DNS flaws. SIGRed is named after the SIG records that can be used to trigger the vulnerability. To exploit it, the attacker needs to create and publish a SIG or RRSIG record on an authoritative DNS server on the internet, which is kind of rare. Then the attacker needs to figure out how the organization DNS server will look up the record. Luckily, Checkpoint researchers found a creative way doing that by simply get someone to visit a web page in order to induce the browser into sending a DNS query to a nearby DNS server. Now, before you start panicking, start by checking if you are affected. Basically, all versions of Windows Server are vulnerable, but only if you're running a DNS server mode. If your organization does not have a DNS server or uses a DNS server based on a different operating system, you have nothing to worry about. Well, for now. Luckily for us, the vulnerability was discovered by Checkpoint research and not by the bad guys. And no public information about exploiting it exists at this time. Also, this is currently no evidence for the vulnerability being exploited in the wild.
I just want to add, however, don't underestimate this vulnerability. Some threat intelligence sources claim that cybercriminals have already started pouring out vulnerable DNS server, trying to figure out how to exploit it. So we really recommend patching as soon as possible. In short, here's the recommended remediation strategy. First, detect all your DNS servers at the organization, especially the Windows ones. Then, the most straightforward solution is, of course, to install the Microsoft patch, which modifies the method of handling requests by the DNS server, the most hermetic solution. But if you can't update for any reason, Microsoft also suggested a workaround for this vulnerability. Make the following registry change. We'll write more in our Slack channel and keep being posted. Just, I want to add that you must restart the DNS service, for the registry change to take effect, and basically to to the workaround to take effect. And another thing, keep in mind, before changing the registry keys, make sure you write down the former registry keys values, because after installing the patch, it's really recommend to undo the workaround for on the server, because only then you will able to deal DNS name for the clients when the DNS response from the upstream server is larger than 65,280 bytes. More information in our Slack channel. Please feel free to ask questions and read more about it. So let's wrap it up. This is a very cool and creative piece of research by Checkpoint. We've been lucky, frankly, that they were the ones who came out with this vulnerability. So now we can patch away in a less stressful way. However, let's not be too carefree and make sure to remediate this vulnerability as soon as possible.
Now let's dive into another big vulnerability that was discovered last week. And again, we're seeing a very dramatic headline. BootHole. BootHole is a huge vulnerability in Grub2. Bootloader leaves millions of Windows and Linux systems at risk from hackers. So why this vulnerability is getting so much exposure? Mainly because of the huge impact. Because all signed versions of Grub are vulnerable, every Linux distro using Secureboot with standard UEFI certificate is affected alongside a lot of Windows machines. Okay, this is a really big deal, but first let's take a deep breath and understand if we are vulnerable. In order to exploit this vulnerability, the attacker must have root admin access or have a physical access to the assets in order to access the grub CFG file located in the EFI system partition. Okay, so let's back up for a minute. What is a Secureboot and what can attackers do when they bypass it? Secureboot, as the name suggested, is designed to verify that all the firmware required to start up the computer is trusted. It does so through private and public keys, whitelisting and blacklisting, databases that call DB and DBX. And what can happen when bypassing the Secureboot? So if an attacker would bypass the Secureboot, the asset would essentially be helpless against malicious activity, basically since the power on button pressed. Even before the OS booting, and a lot of security tools are loaded too. This kind of attack would expose the organization to some serious malicious activity, like persistent bootkits and rootkits, ransomwares, crypto miners, keylogs, and data leakage.
So briefly, here's how Secureboot works for Dummies. The Secureboot stages. The first firmware first stage bootloader binary that contains a trusted certificate known as shim is loaded. Then the shim loads another bootloader called grub and validates it with the certificate. Now the tricky part, grub loads where the kernel image should start alongside required configuration from the grub CFG file, which is not signed. I give you a little spoiler. Grub validates the kernel through keys stored in the firmware trust database, DB and DBX, as Ortal mentioned before, and the authorized and forbidden signature database. Then grub hands over the control to the kernel, and then the kernel boots the OS, as we all know and use. So where the vulnerability kicks in order to read the config file mentioned in stage 3, actually the grub CFG file, the grub uses a language parser. If the config file is too big, the parser will throw an exception and stop the processing function. But the real problem here is that grub not expecting this exception and just ignores it and copies the content to the memory, as is, and continues. So essentially, attacker can write massive string into the grab CFG file, which we already said that it's not signed back there in the spoiler one, and create a buffer overflow, which can give him the ability to write to the system memory and potentially do whatever he wants before system is booted. Should it concern us as InfoSec? Some InfoSecs will tell you that Secureboot was broken for years and yet nobody cares. Others use it to protect sensitive systems in regular basis. It really depends how your organization works and implements Secureboot or not. Please check it out. Even if you're using Linux in the cloud, you must not be impacted at all. We recommend you check with your cloud provider if the instances and services use Secureboot. For best of my knowledge, AWS and Azure instances doesn't support Secureboot and aren't affected. But Google instances might be in GCP. Just check it out, double check me. I'll check again and update in the Slack channel. Feel free to ask us there.
Now, is there a patch? In short, while the patch is relatively straightforward, it seems to have a huge logistical challenge around it. First, the issue must be fixed in grub2. Then, in all Linux distros, vendors and maintainers should update their bootloaders, installers, and shims. These new shims need to be signed by Microsoft, who, as it turns out, is the designated signer of the third-party UEFI certificates. Then comes the tricky part. Microsoft should release an updated deny list, DBX, that will block malicious shims that can load unpatched version of grub. The problem is that updating the deny list, the DBX, before you updated the bootloader or the OS could result a broken system and workflows. So why shouldn't patch blindly? Even though the bug was first reported in Red Hat Enterprise Linux, related patch reports are rolling in from other distributions from different families as well. Ubuntu and Debian users are reporting systems which cannot boot after installing grub2 updates, and Canonical has issued an advisory including instructions and recovery on infected systems. About workaround and mitigation. So there are some workarounds available, but keep in mind that these are risky and often untested. For example, Microsoft has suggested an untested mitigation to manually install the DBX update. Keep in mind that this mitigation is untested and could be risky, but if you decided to go for it, test it first and do it slowly. Personally, I would recommend waiting for tests and confirmation before applying it.
Our recommendations. First, detect, see which assets are vulnerable and try to map your organization and see the risk, estimate it. And then make sure all vulnerable assets aren't vulnerable to other privilege escalation vulnerabilities. And keep in mind tracking more carefully about user escalating privilege generally, because as we said, to exploit this vulnerability, the user must have admin or root rights or physical access, so guard your computer well. That's it. And the third thing is when you go to OS updates, please update with caution and test the related OS updates thoroughly before applying them across the organization. Search for recommendation and issues occurred in the community. Linux have a great open community. You can find lots of people with problems similar to you. And of course, you can ask us in the Slack channel. Another tip is to track the revocation list updates. Be sure to specify the test at the same firmware version and models that used in the field. It may help to update to the latest firmware first in order to reduce the number of test cases. And again, do it slowly and test it first. It's important to make sure all bootable media has received OS updates first before you deploy the revocation update. Roll it out slowly and in small number of devices at a time, and incorporate lessons learned from testing as part of this process. Explicum released a detection script that helps you to see if you're using Secureboot and if your binary is revoked or not. So please use it in the process. It's a nice tool, and let us know how it was and thoughts at the Slack channel. Eventually, when the time will arrive, create an action plan to remediate this vulnerability. When the updates will be available and stable, start with small batches again before rolling out to the entire organization. Please learn from the mistakes, from the tests, from the community, and plan according to the risks, the best remediation campaign. If you need help, please, again, you can contact us at the community.
So while BootHole is not critical yet, it could change fast if attackers will automate the whole process and wrap it nicely as a tool. When that happens, BootHole should be definitely on your radar. The remediation process is long and could potentially be painful. It's possible that more organizations will get damaged from patching issues rather than exploitation of the vulnerability. So please do it carefully and in small steps, and good luck for us all.
That's a wrap for today. Thank you for tuning in. We hope you enjoyed it, and we'd love to hear your thoughts. If you have any questions or comments, we'd be more than happy to speak with you directly through our Slack workspace. Looking forward to seeing you on the next Vulnerability Report.